things on here because it's been a while for some of you from algebra. So I put slope-intercept form, but I also put these other two types of graphing lines, point slope form and standard form. I was going to show you the method. Just because you're in pre-calculus now, it's kind of nice to learn a little bit of something new. But if you want to use slope-intercept form as your fallback, you always have it as your fallback. So you know that y equals mx plus b is slope-intercept form. And this one is given right in that form. Your slope is 2/3 and your y-intercept is the -2. So you're going to start at -2 on the y-axis, and your slope is rise over the run. So I'm going to go up 2 over 3. And I can put a couple dots and then connect it and draw a line. My Algebra 2 class had a bunch of rulers out, so if you want a ruler to draw a straight line, you could. But and if you want to add like that this is the slope and that this is the y-intercept, if you need to remember that, that's good. You always read a graph from left to right, just like you read a book. So as I read this graph is going up. So this is positive slope going up. As I read it from left to right, if it's going down, then that's a negative slope. Okay, so point slope form. I just wanted to show this to you. So I'll show you converting it into slope intercept form too, but there is a point and there is a slope. So this value right here and this value right here give you the point. And you know your transformation rules, how inside the parentheses everything's backwards? This takes you left 1. This is in a parenthesis. So this actually takes you up 3 units. So inside parentheses, things are backwards for transformation rules. So this is taking you left 1, up 3. So I want you to write down the point, -1, +3. So that point lies on this line. So I can graph the point -1, 3 and put a dot right there. It's kind of like it's your starting point. Oh, I'm on the wrong graph. Whoops. -1, 3 is right there. What's your slope? So your slope is sitting in front of your parentheses. So your slope is -1. So from this point, you can just go down 1 over 1, and you have a slope of -1. And some of you might be like, oh, I hate point slope form. It's something new. To me, it's easier if it's in this form than trying to go through the algebra to convert it. I know that this will give me a point and this is my slope. If that's confusing for you, go ahead and just distribute, right? So what if you distribute this -1, right? You have y minus 3 equals -x minus 1. And then you would add 3 to the other side. Y equals -x plus 2. There's plus 2. There's your slope of -1. So if you convert it into slope-intercept form, it'll come out the same as doing it using the point slope form strategy. So if you just want to convert everything with the distributive property back into slope-intercept form, that's fine. I don't care what method you use. You're in an advanced math class now, or pre-calculus is an advanced math class. You can graph a line any way that you can. Okay, so standard form. So again, you could use the strategy, and I'll show it to you in a minute. How do I convert this into slope-intercept form? But I just want to show you the standard form strategy, because some of you might be like, oh, that's a cool strategy. I'd rather just do that. Standard form, you can find your x and your y intercepts. So if I cover up this x, right, if x is 0, I'm somewhere, oh, sorry, this point was a typo. I'm somewhere on the y-axis. If I plug in 0 for x, what does y have to be to make this true? 3 times y equals 6. 2. 0, 2 is my y-intercept. All right, what happens in my original equation if I cover up the y value? So now y is 0. What would x have to be to make it true? 2 times x equals 6. So if x is 3, then y gets to be 0. So I can plot my x-intercept. And then if you have any 2 points, you can draw a line. So I'm just covering up that little mistake that I made in pen. So you plug in 0 for x, you find y, you plug in 0 for y, you find x, and any 2 points make a line. So if you hate that strategy for standard form, then you need to be able to convert it into slope-intercept form. How do I solve this for y equals? I would subtract the 2x to the other side. So now I have 3y equals negative 2x plus 6. Then I would go through and divide by 3. So I'd have y equals negative 2/3 x plus 2. That's exactly this line. I started at 2 and I went down 2 over 3. You could also do it both ways. That would be a good safety check that you did everything correct. You did it in standard form, you converted it and checked it in slope-intercept form. If they don't match up, you did something wrong. So you need to be able to graph a line. I don't care how you do it, besides you can't use a calculator. So convert it to the other form or use one of those strategies. So there's some practice you can try after lunch. 4, 5, and 6 I put on here again to practice graphing the absolute value graph. So let's do these together. What are my transformations on number 4? There's 2 things happening. What does the minus 2 do? Shifts it to the right. Right 2. What does the plus 1 do? Up 1. So if you want to draw the parent function in and then shift all the points, but the parent function for absolute value is easy, right? It's just a V-shaped graph that comes out of the vertex. So let's just shift our vertex. Right 2, up 1. I'm just going to draw my V-shaped graph from that new vertex. And it has a slope of up 1 over 1 and up 1 over 1 in the other direction, unless it's been stretched or flipped. So number 5 is a little bit different. What has happened to number 5? Shrunk. It's less tall, so it's a vertical shrink. This one, I'm actually going to zoom in on a little bit because it's hard to see where the 1/2 is. So 1/2 actually becomes the slope of the absolute value v. So you're not moving anywhere. You're starting at 0, 0. Your line just gets a slope of 1/2 when it's absolute value. Because absolute value is just a linear graph going in the 2 directions. The slope of the linear graph becomes a half. It's a little bit easier than when you have a quadratic or a square root function that you're shrinking. This is just, it becomes the slope of the line. It goes forever. If I asked you, what's the domain of this function? All real numbers. It goes side to side forever. What about up and down? What's the range of this function? Y is what? Up here. Greater than or equal to 0. So I'm not focusing on domain and range yet, but I hope you could answer a domain and range question maybe. I've got 3 transformations going on here. I've got a negative sign, I've got a 3, and I've got this plus 4. So what are my transformations? What's one of them? Left 4. What does the 3 do? Stretches it taller. And what does the negative sign do? Stretch, and this flips it over the x-axis upside down. So I'm going to shift my vertex 1, 2, 3, 4 to the left, and then I can do this negative 3 part all at once. It's basically just going to make it a slope of negative 3 going down because it's absolute value. So down 1, 2, 3, and over 1. 1, 2, 3, over 1. 1, 2, 3, over 1. There we go. So there will be a linear graph on your quiz tomorrow. There will definitely be absolute value graphs with these transformation rules. It might just be stating, oh, this is left or this is right, or graphing them by hand, or you might have to write the equation. So I might give you, like, I might print this graph, and your answer is writing this equation out as your answer. So the transformations in the equation. Okay, the next one, piecewise functions. Might throw this in as a bonus. I'm not going to have you graph these and grade you on these, but to me, you can graph a piecewise function if you can graph the different functions. If you don't have a pencil, you want a pencil for piecewise, I'll just wait till I put up the final answer because I'm going to draw the graph and then I'm going to erase part of my graph. So like at first, I'm just going to graph y equals 2x. I'm just going to graph the whole thing. Then I'll show you what part you're going to erase. So don't graph the whole thing if you don't have a pencil. What's my y-intercept if it just says f of x or y equals 2x? What's the y-intercept for this function? If it doesn't have one, it's at 0. So I'm going to start at 0, 0, and I'm going to just do a couple points that go up to over 1, down to over 1. But I'm not going to connect the line yet. I need to erase part of this line. This says I only do this function when x is less than 0. Do I want to save the right side of the graph or do I want to save the left side of the graph? If x has to be less than 0. Save the right side. X has to be less than 0. These are the x values that are negative. So I'm going to keep this side of the graph, and I'm going to get rid of all the points that are to the right side of 0, because I'm only doing a piecewise function. And you're going to put an open circle at 0, 0, because this says x is strictly less than 0. So I can't actually equal that point, so I'm just going to have a line array going this way. There it goes. So it's this portion of the graph when x is less than 0. So now I'm going to do the second part of this graph. So now I'm going to graph the function 1x plus 3. So I'm going to start at 3, which is right here on the y-axis, and it just has a slope of 1, up 1, over 1. It would fail the vertical line test right here, right? So I know that I'm going to have to erase part of this graph. X has to be greater than or equal to 0. So I'm going to keep this point, and I'm going to do array in that direction, because the x values have to be greater than or equal to 0. I'm going to keep that as a filled in dot. So this dot got to be filled in because when x is 0, I'm going to use this function, and this point is not filled in because I'm not going to plug 0 into that function. That's a piecewise function. Might be your first time ever graphing one, so at least you've seen one of those before and how to restrict the domain, and it's just graphing lines. You're just erasing part of the line. All right. So let's do another piecewise function together because these are difficult. And then maybe you can try example 2. All right, so remember, I'm just going to go for it. I'm going to graph this line, 2x minus 1. Then I'm going to do my erasing. So let's see. My y-intercept is -1, and I have a slope of 2. Up to over 1, down to over 1. So that way you don't have to think too hard. You just graph your line. And now you think about my x values have to be less than or equal to -2. Well, that's way over here. So all these x values are less than or equal to -2. So this is the part of the graph that I want to keep, right? Because this part, like x is positive 2. I don't want this part of the graph. So we're going to keep, let's see, where does it start? At -2. I'm going to keep this point filled in, and I'm going to go in this direction. And I'm going to erase all these other points. So that's x is less than or equal to -2. What does 4 mean? So it really means y equals 4, right? Because there's an f of x equals, so this is really y equals this, y equals this. This is a horizontal line. Y equals 4 is a horizontal line. It's a constant. All right, so it's a horizontal line, but where do I need to erase it to stay between? X has to be between -2 and +2. So at -2, I'm going to have an open circle, and at +2, I'm going to have a filled in circle. And that's it. That's the only part of the horizontal line that I'm going to keep. So open circle here. X is strictly greater than -2, but less than or equal to 2. So I've got this horizontal line and that. Does the function exist at f of 6? Yeah. So f of 6, you just say is undefined. I'm thinking more like an SAT question. There is no f of 6, right? 6 comma, there's no point. What if I ask you, what is f of 1? Well, f of 1 is 4, because that's where that point is on the piecewise graph. So being able to answer a question from a piecewise graph, not for your quiz tomorrow, but I'm going to have you at least graph lines tomorrow, and I might ask you about domain or put this on there as a bonus. All right, you try example 2. See if you can graph it, restrict the domain, graph it, restrict the domain. Both of these have a y-intercept of 0. If that is confusing to you, just add a little +0 after each equation. I love Lou's little leg pose here. He like stretches his leg out here. All right, let's see. Right, so I read it as x is bigger than 0. Because to me that makes sense when I'm graphing my inequality. Let's see, -2x would look like this. I want to keep that on this side, right? Oh, this one seems a little tricky because -2x is this line, and it says x is less than or equal to 0. The x values are. All right. Peace. I'll see you right after lunch. So it actually rings up. This part is graphing the -2x. Now I need to graph the 1/2 x, right? So I need to start, I need to start at a y-intercept of 0 and just go up 1 over 2, right? And this is when x is greater than 0. So I actually can just graph it and just leave off this other tail, right? So if I did this with a color, this is this purple line right here. And then the other line is that pencil line. And if you notice, this filled in circle right here, this guy gave us the 0. This would have been an open circle, but an open circle on top of a closed circle is still a closed circle at 0, 0. So this one's coming in and this one's leaving from that same point. So if they come in and they overlap, then you just leave it as a filled in circle for that piecewise function. All right, I'd like you to take a minute on your own to try example 3, graphing the two linear functions and finding where they intersect. One of the lines is not given in slope-intercept form. So you can either graph it the way it is or convert it into slope-intercept form. So why don't you see if you can try 3 and 4 kind of as quiz review. Working if you don't need that. So I've got -2x plus 8. So I think most people got this part no problem. Here's my -2x plus 8. I forget how far I have to go to find my intersection point, but so there's that line. Then you've got the choice on line 2. You can convert it into slope-intercept form. but you end up with a y-intercept that kind of hangs off the graph. Or you can graph the point 4 comma -4, right 4, down 4, and that is going to be a point that lies on your line 2, and then the slope is 2. So you can kind of see from that point, it intersects right away at, did you get that it was 5 comma -2 as the coordinate? So there's nothing wrong with converting it into slope-intercept form. You would do y plus 4 equals 2x minus 8, and then you'd have to subtract the 4 to the other side. So you'd have 2x minus 12, and it would just end up hanging down here when you graph it. So you'd have to very carefully get back on the axis because I didn't really leave you enough room. But you could graph the intercept at -12 if that was your method. So the other one, they wanted you to graph the absolute value transformation and then state where is this below the x-axis. So they want you to go for your vertex right 3 and down 4. So right 3 and down 4 is your vertex. Absolute value is that V-shaped graph, right, that goes just a slope of 1 if it hasn't been stretched. You really want to see where you hit the x-axis. And then you can see what's below the x-axis. So you want to write an inequality that describes, okay, x has to be between what and what? Where is x? Where is it going to be below the x-axis? So way over here, this looks like -1 on the x-axis, and all the way over here, this looks like what? +7. So if x is between -1 and +7, I will be below the x-axis. So it's a little bit of a stretch on kind of a domain question. What values of x put you below the x-axis?